Hello students, today we are going to prove a very important result of discrete mathematics, and this is a theorem. Suppose A is a set, R is in equivalence relation on A, and A and B are the elements of A. If A is related to B, then class of A is equals to the class of B. Now, there are some things given. A is a set, R is an equivalence relation on A, and A, B are the elements of A. And this is A is related to B. Then we have to prove that class of A is equals to the class of B. Now, we will prove this theorem in two steps. We will prove this theorem in two steps. Number one is A is a subset of B, equivalence class of A. This means class. Equivalence class of A is a subset of equivalence class of B. And number two, equivalence class of B is a subset of class of A. We are saying that these are subsets of each other because we know that equivalence class is basically a subset. I mean a set. Equivalence class is basically a set. X such that X is related to A. Means all the elements that are related to A are in the class of A. Okay, now for step number one, let X belongs to the class of A. Now we have to prove, we have to show that X belongs to the class of B. Since X belongs to the class of A, by the definition of equivalence class, X is related to A by the definition of equivalence class. Now, we are given that A is related to B. It is given here. If A is related. Now, X related to A and A related to B. Then X is related to B. This is transitivity by transitivity. Because R is an equivalence relation. We know that the equivalence relation is reflexive, symmetric, and transitive. So any of the three properties we can use in this theorem because we have this set as an equivalence relation. Okay. So when X is related to B, we have now seen that X is related to B. It means that X belongs to the class of B by the definition of equivalence class. X belongs to the class of B. It means that A, class of A, is a subset of class of B. Because we assumed that X belongs to the class of A, and now we have proved that X belongs to the class of B as well. It means that class of A is a subset of class of B. Now this is our first step. We name it as equation number 1. Let us move on to the second step. Step number 2. Now in the similar way, we have to prove that let Y belongs to the class of B. We will show that Y belongs to the class of A. Since y belongs to the class of B, means that y is related to B. And the reasons are same, because by the definition of equivalence class, y is related to B. Now we are given that A is related to B. We were given A related to B. And since this relation is an equivalence relation, it means that by symmetricity, B is related to A. By symmetricity. B is related to A. And again, we apply the transitivity. Y is related to B, B is related to A, implies Y is related to A. And then Y belongs to the class of A. This means Y we suppose that Y belongs to the class of B, and we have proved Y belongs to the class of A. It means that B is also a subset of A. This is equation number 2. From 1 and 2, we see that both classes A and B are the subsets of each other, implies class of A is equal to the class of B. This is it. Now, if you like the video, please give it a thumbs up and please subscribe to my channel. Thank you.